Hello YouTube, I am Arend and today I will be showing you how to do top-down random terrain generation in GameMaker. Although you could pretty much, if you understand coding concepts, you should be able to follow this and apply it to basically anything. We'll be doing this with Perlin Noise again. This time we'll be expanding our Perlin Noise knowledge to 2 dimensions. So, it should be pretty fun. With that, let's get into the tutorial.
Alright then, let's get started. So here's our final product. By the end of the day, you'll be able to generate terrain in this manner. And by hitting space, we can restart. And you can see it generates perfectly random terrain, but it looks like terrain, doesn't look like just random noise. So it's pretty neat. Today, you can follow along the tutorial. You can learn to make this. The code is also available in the description if you so wish to use that. So for our starting point, we're actually going to start from where I ended on a previous tutorial, which is the GameMaker Terraria terrain tutorial. So there'll be a link in the description to that as well. And in that one we generate this. So we generate this type of terrain. And we're going to use a very similar process, just extending this to 2 dimensions rather than 1 dimension. And we'll be able to generate what I just showed you. Alright, so with this as a starting point, let's get going. So there's going to be several things we're going to want to remove here. So we no longer need sprites since we're just drawing it ourselves. So I'm going to go ahead and delete those sprites. And additionally, you can delete the objects associated with those sprites. Alright. I'm going to jump into the creation event of our generator. Block size no longer dependent on the sprite, so we're just going to plug a number in here. You can change this number depending on what resolution you want. There's not going to be a max height. We're going to create a width and a height based off of the dimensions of our room, how wide and how high our grid is. So we're going to say our width is equal to our room width divided by our block size, and likewise our height is going to be our room height divided by our block size. There we go, we have our dimensions. So we want to basically store a 2-dimensional array storing all of our values, which will correspond to the color of each of our blocks in the final product. So we could do a 2-dimensional array, but since GameMaker has some data structures for us, let's just use that. Might as well. So we're going to call it a grid, and we're going to set equal to a ds grid create. So ds grid is basically a 2D array, except there's some extra things you can apply to it, which can be handy sometimes. So with the constructor, we give it a width and we give it a height, and there we go. Let's see. So next we call generate. So let's look how we need to change this. So our current Perlin Noise system is actually only good to generate 1 row of the terrain I just showed you, so we're going to do that in such a way that'll do it that way. So rather than finding a height, I'm going to call it ZZ actually. I'll just make it max of 100. So it'll give us something between 0 and 100, and I'll take that away. And we'll call it Z, because, you know, if X is along the width, Y is along the height, we'll just say Z is along the depth. Okay? Alright, so we have our ZZ, and then we're not going to loop to create a bunch of things, so we're going to take that all away. And we're actually going to restore the result in our grid so it can be drawn later. So we're going to say ds grid add, looking at these parameters here. So the data structure that we're adding to is our grid. We called it grid. The XY we want to add it to is I, representing our X, and 0. Like I said, this only generates the first row, so we'll keep our Y at 0 for now. And the value you want to plug in there is the ZZ we just found. Alright, that's all we want to do over there. And now we're going to have a draw event in here. We're just going to draw all of our blocks. So I'm going to create a loop for our I equals 0, I is less than our width. Which, by the way, I did do that over here, didn't I? Yeah. Instead of this, we're just going to say width. So that's the number of blocks we fit in our room, so we're just going to do it that way. I guess I don't need this XX anymore either, so it's just that. Alright. Okay, so in here, we're going to have a similar loop over the first row, and then for each one we're going to draw a rectangle. Okay, we're going to say draw rectangle, and let's see, the X value I want to draw it at is at I times the block size. So our block size is 8, so when I is 0 I want that to be 0, When I is 1, then we're at the second block, so we want our xi to be 8, and so on, and so on. So it's just I times block size. And then after that, we are plugging in for our y, so it's just going to be on the top. So we're going to have 0 for our y. Now the second x is going to be on the right side, so it's going to be basically at the next block, so that's I plus 1 times block size. And then for our next y, it's going to be block size, since this is our block size. So if the top is 0, then the bottom should be 8 pixels down, or our block size. Is it outline true or false? That'll be a false. It's not outline. Alright, I'm probably going a little bit fast. I hope it's making sense so far. Yeah, I'm just really excited to get into the cool stuff. Alright, so let's just take a look at what we have so far. Make sure we don't have any errors, which we very well may. Alright, that's not looking the way I want it to. Well, that's because, well, it's all black, and that's because we never changed our color. So we're going to do draw set color, and we're going to say make color RGB, and want it to be based off of the value at this point in the grid. By the way, when we're generating these things, I use grid add, but that's kind of an annoying way to do it. There's an easy way that the GameMaker has to do it. These are called accessors, and most data structures, in fact, I think all data structures in GameMaker have this. So let me show you just an easy way to do the same thing. And since we're going to be doing this a lot, this will be worth our time to learn. Let's see. So icon 0 equals ZZ. There you go. I guess about 33% reduction in code length there. So this is just a faster way of doing the same thing. So we're just accessing I and 0, and we're setting equal to the ZZ. I think this is more logical as well. Okay, so we're going to do a similar thing here. We're going to set the red component to be grid, let's see, that'll be hash I comma 0. And likewise, we're going to set our green component to be that same thing, and our yada yada yada. Cool. So now we're setting the red, green, and blue components all to the same value that we generated between 0 and 100. So this will be grayscale. Let's see, so if I play it, let's see how that looks. There we go, that's more like it. So you can see it's kind of gradient. It's smoothly changing from one value to another along this top row. So you can, if you watch the Terraria tutorial, you can kind of think of this as looking at the Terraria train from like a bird's eye view. So we're looking at it from above, and maybe the darker areas are lower terrain, whereas lighter areas are higher terrain. So that's how that same one-dimensional Perlin noise algorithm is being represented here. It's just one line. So that's where the one-dimensional Perlin noise fits in this, and that's kind of the overlap between the Terraria terrain and what we have here. This is just looking at it from a different angle, but the same data. Alright, the next thing we're going to do is we're going to add some nice color to this, not just make it grayscale. You saw in the beginning we were using some various shades of blue and green, so we're going to try and do that same thing. Rather than set the color to this gray thing we made, we're going to create a new function, and we'll call it getColorZ, because it's kind of based on the Z values. That's what I thought would be a good name for this. Alright, and we're going to go ahead and create that script, call it getColorZ, and here's what it's going to look like. So we're going to take in our Z value, so if our ZZ equals argument 0. Well, okay, let me first clarify how we're going to call it. So the Z value that we want to find a color for is, of course, the grid value. So it's going to be grid hash I comma 0. So the way we're going to do this is we're going to create our RGB to start off with. So we're going to set R equal to 0, we're going to set B equal to 0, and we're going to set G equal to 0. Alright. Now, if our ZZ is less than 50, we pretty much want it to be blue. Otherwise, we want it to be greenish. So here's how we're going to calculate our blue value if Z is less than 50. Since Z is between 0 and 100, and in here it's actually between 0 and 50 because we already determined that's less than 50, I'd like to turn it to a decimal between 0 and 1, corresponding to between 0 and 50, because math is easier that way. So the way we're going to do that is we're going to just say ZZ divided by 50. So if ZZ is all the way at 50, at its highest that it can be within this section, then it's going to be at 1. and if it's at lowest, it's going to be at 0. And we're going to multiply that by 200, and then prior to that, we're going to actually add 50 to that. So if you think about it, depending on what z is, remember it could be between 0 and 50, this equation right here will spit out a number between 50 and 250. So it'll be like between a dark blue if z is really low, or a lighter blue if z is high. So that's how that would work. We're going to do a similar thing for this part, which is calculating the green value. So we're going to do convert into a decimal again. So we're going to do a similar thing. So it's actually going to look a little bit more complicated, but not going to be too bad, I hope. So for this one, if it made it over here, remember, z is originally between 0 and 100. It didn't go in here, which means in here it's between 50 and 100. So I got a 0 at the lower end, which is why I subtract 50 from it. So now it's between 0 and 50. And then we're basically at the same situation as we are here. This is number between 0 and 1. And we'll do pretty much exactly the same thing. We'll multiply it by 200, put parentheses around the whole thing, and we're going to add 50 to start with. Alright. Awesome. Now we're going to turn a new color. So make color RGB, and then we're going to do RGB. That's our basic algorithm for determining the color. And I'm going to play, and we have an error. Well, that's to be expected. Made it fairly far, actually. Alright, that's not supposed to be a parenthesis, that's supposed to be a bracket. That's our error. And we still have an error. We need 2 parentheses over here. Alright. Now you can see, you can kind of begin to see that this is how this can eventually turn into the terrain we saw in the beginning. This is just one slice of it, and the rest of the tutorial is going to focus on how do we take that one slice and generalize it to be able to create a whole 2D grid of it. And I'm pressing space, using the restart that we made in the Terraria thing, I can kind of see what it looks like. Alright, very, very cool. Alright, so we're going to jump into the fun part of updating our Perlin Noise to work in 2D. So we're going to start in our generate to actually make it fill the grid in 2 dimensions rather than just 1. So to that we're going to need another loop. This outer loop goes through the width. So for each, you can think of this one going through the columns. So now we're going to need another loop to actually go through each row in the various columns. So I'm going to loop j equals 0, j less than height, because it's going to go through the height, and then j plus plus. There we go. All going through the rows. And I'm tabbing that out. Okay, so rather than setting I and 0, we're going to set I and j. Not doing the first row anymore. And this get Perlin noise is going to need to be adapted as well. It's actually going to need to take another parameter because we want to generate the noise based on our I and j value. So to further signify that's different, I'm going to actually rename it to 2D. Not 3D, that's next time. 2D. So now to create the script, I'm just going to duplicate our old script and we're going to rename it. And now we will go ahead and start generalizing the script to work in 2D. First off, got to update our inputs. So we're taking a YY as well as an XX. And that is argument 1. And then this will turn to argument 2. Alright, scrolling through here, our chunk size, good. Noise, that's good. Range out by 2, still don't want to do that. This is good. Chunk index is a little bit of a misnomer, if you will, because we're not just basing our index on x anymore. We're actually basing it on index on the x-axis and our index along the y-axis. So I'm going to rename that, and I'll do yy div chunk size. Let's see, before I get too much further, I should probably explain to you the logic behind what we're going to do, because if I can just type out the code real quick, but you're not going to understand it if I do that. Even the reasoning behind this might be a little bit abstract. So, luckily, I set up a little presentation for you guys. Alright, so here's what we had last time. We have index to the left, or rather 0, and we have index to the right, or 1. And what we're interested in is if we have a pixel that's in between them, how to figure out what the value is. So our index to the left, or 0 rather, has a random value. Let's see, in our code we called that random value left random and right random. Just to make it a little smaller, I'm calling them R0 and R1, but those are the left random and right random. And then the question is, if we're processing this pixel over here, what value is it if our left value is this and our right value is that? Make sense? So we calculate how far we are in between them, and I'm calling it t. In our code we actually called it prog right there. So I'm just going to call it t, again, to make things a little more concise. And t can be between 0 and 1. 0 meaning it's all the way towards the left random value, and 1 meaning it's all the way towards the right random value. So again, the question is, what is this question mark? What is this value between R0 and R1, which is, t in between it? So we answered this question last time, and we did it using this fairly simple equation. It's called linear interpolation, or lerping. So if we lerp between R0 and R1 by this progress t, then the equation looks like this. The output looks like this. It's R0 times 1 minus t plus R1 times t. So this makes sense, because if t is equal to 0, then we'll end up with R0, because 1 minus 0 is 1. We get 1 times R0. We get R0. This will be equal to 0 because t is 0. Likewise, if t is equal to 1, this portion will be equal to R1 because it's R1 times 1. This portion will be equal to 0 because it's R0 times 0. Alright? This is just a review from last time, just getting you in the frame of reference. So now, of course, since we're working in 2 dimensions, it's going to look a little bit different. This is the problem I'm working with now. You can kind of see why I decided to simplify the random variables. We have a point here they want to find the value of, and there's actually 4 corners, because we're not just within a one-dimensional range, we're within a box now, a 2-dimensional box. So we have R00, our up and to the left random value, our R10 up and to the right random value, R01 down to the left random value, and R11, which is down to the right. So we have some more variables to work with, and of course there's more progress variables as well. So we may vary between the left and the right by this tx variable, but we also vary between the top and the bottom by this ty variable. So we have 2 progress variables to throw in the mix as well. Alright, how could we possibly do this? And also, just to clarify, when I say R00, there's 2 numbers there, and the first one is going to represent our x, and the second one is going to represent our y. That's just my notation. So you can see the ones on the left have an x value of 0, and the ones on the right have x value of 1. Alright, so how can we possibly solve this problem? So we're going to start off by calculating for these 2 points. So this is going to be along our y-axis. So we're going to find this variable, this random 0, which is going to be between R00 and R01. And of course the proportion between the 2 is ty. And likewise R_1. The proportion is still ty, but it's between these 2 different random values. So how do we find out what these R0 and R1 is? Fairly simple, if I dare say it. It's just 2 linear interpolation algorithms. So again, R0 is just between R00 and R01. R1 is between R10 and then R11, and they both vary by t_y. So this is interesting, because we've basically taken this complicated problem, this 2-dimensional problem, and we've broken it down. I like to think we squashed down the y dimension. We've squashed it down into a 1-dimensional problem where it turns into a linear interpolation between 0 numbers. So basically, after doing this simplification, what we end up with is that. We end up with this. It's just we need to find a value between R0 and R1. Look familiar? It should, because at this point it's exactly the same as our the 1-dimensional problem we solved at first. We've completely eliminated the 2nd dimension, and we are back down to a single-dimensional problem. And then the value for this question mark over here, this is just going to be our linear interpolation between R0 and R1 by t_x. Alright, you understand this? Good, well done. this is the core concept that's going to be the trickiest to code. So with that, let's go ahead and write our algorithm, shall we? Okay, so we need 2 indexes. This is going to correspond to our top left corner, if you will. We can figure out the indexes for other ones just by adding 1 in different combinations. Okay, we need 2 progresses. To be consistent with my little slides, I'm gonna rename this variable to t_x. That cool? And then we're gonna need to do it again, and we're gonna this time it's gonna be t_y. And of course, t_y is gonna be along the y value instead of the x. If x is 24, we would have passed 1 chunk, so then there'll be 24 div chunk size, which is 24 div 16, and that would be 1, assuming x is 24. And likewise, this would, if it's 24, it'll be x% chunk size, which will be 8, which is what you get left over, the remainder after you divide by the 16 from chunk size. And then we divide by chunk size, which will tell us that this is halfway between our chunk index and our chunk index plus 1. And then that's just the same thing along the y-axis. Alright, so far so good. Now I'm going to rename these. We're actually need to create some more of them. So we have our 0, 0. We have our 0, 1. And, well, actually I'm going to call it like that. So we have our 2 x values, and then we're going to have 2 more for when our y's are in the upper range. Alright? So this random seed is going to need to change a little bit. We're going to actually need to have it take an extra parameter. So it's not chunk index, it's index along the x, and it also needs to know the index along the y, comma. And then to make it easier on myself later, I'm going to actually move this range to be the first parameter as opposed to the third parameter. Alright? And I'm going to actually copy this over and over again, because I can just adjust that. Alright, so this is 0, 0, meaning we just do index x, index y. This is 1, 0, meaning we do index x plus 1. This is 0, 1, so we do plus 1 on the y. This is 1, 1, so we do plus 1 on both. Alright, so the next step is we need to adjust our random seed function, because we only wrote it take 2 inputs, and now we're giving it 3. So I'm going to have to adjust that. Okay, random seed. So our range is now the first argument, so we're going to write it like this. Alright, and now we're going to take in a YY, but I still want this to be capable of handling the single dimensional version, because I still want my get Perlin noise over here to work. So GameMaker actually has a system where you can take in multiple arguments. I made a tutorial about that, how to make scripts with taking multiple arguments, and you can find a link to that in the description. So the way I'm going to do this is I'm going to create a switch statement. I want to do different things depending on its argument count, depending on the number of arguments that are inputted. Ooh, argument. In GameMaker, tab completion is implemented using enter. It feels weird to me. We're going to find a value, instead of calling it XX, I'm going to call it num, just to make things easier. So initialize it to 0 up here, and if our argument count is 2, meaning it's just given the range and a single value, then our num is going to equal that single value. So num equals argument 1. And then we're going to break. That's all for that case. Now for case 3, if we're giving it a range and then 2 values, our num is going to be a little more complicated. It's going to be equal to argument. Let's see. So we want to make it some combination of arguments 2 and 3. Or sorry, 1 and 2. So one way we can combine them is just simply adding them. And there's a slight problem with this. The thing is, when we're asking for a random number over here, if we have 3, 2, and we have 2, 3 as two things we want our numbers for, that will end up giving the same random number in here, because 2 plus 3 and 3 plus 2 are the same thing. So that's a slight problem. If you did it this way, you'd end up with like a symmetry in our terrain, because the top right side would end up having the same seeds as the bottom left side. So you end up having a symmetry across the diagonal. So it might be hard to visualize, but anyway, the way we're going to fix this is I'm going to multiply this by a big number, 65536. Doesn't really matter. So now the values will be more or less distinct. It's going to be a lot harder to find two XY pairs that end up with the same value. the larger this number is, the more effective this strategy will be, because if we just made this 2, then you would still see some symmetry. But if we make the bigger we make this, the less symmetric this will seem. Alright? So that's the way we're going to combine those two. And we break, that's all I want to do. Alright, very, very cool. Now we have our R00, R10, R01, and so forth. Now we can proceed to what we did in the what we were doing on the slides. So we want to squash down on our second dimension. So what we want to take our R0, maybe I should organize these differently. Let's do it like, let's see, I'm gonna organize these differently to make it clearer. Yeah, that'll do. So we have our when our x is 0 and then our y. So we're gonna actually squash down the second value here. So we're gonna combine these two. We're gonna say our var r0 is equal to, so 0, the combination of these two, is going to be the same equation used right here. However, I don't want to type out this equation over and over again, especially since you don't necessarily have to use linear interpolation. You can use various different types of interpolation, cosine, cubic, whatever. So instead I'm going to write a function for it. I'm going to call it lerp. And oh, what do you know, GameMaker already has a function called lerp, and it happens to do exactly this, exactly what we want to do. So since I've already explained to you what this does, I am comfortable using the built-in functionality. It'll do exactly the same thing. So we'll give our two values, R00 and R01, and we want it to lerp by RT of y. Okay, and then we'll do the similar thing for R01 equals lerp. This one's going to be from R10 to R11, and this is also going to lerp by ty. Okay. Now we've squashed down the second dimension. We've reduced it to a single dimensional problem. And then this noise, we're going to add to it the value between R0 and R1. So we have R0 and R1, and the value between it is going to be Tx. That's how far in between we're lerping. All right. If I'm not mistaken, I do believe we have a finished 2D Perlin Noise algorithm. So round of applause for all of you people who made it through this. This is the interesting part. This is the cool math trick which allows us to make interesting Perlin noise, this lerping in 2D type thing. Alright, now let's see. I guess the last thing we need to do is we need to change our drawing. So right now it still only draws a row. Similar to when we were generating our various grid values, we're going to need to do a nested loop to actually draw all the columns as well. So we're going to loop along with the variable j. It's going to go from 0 to our height, and then each iteration is going to increase by 1. Did I make any typos there? No, I think we're good. Alright, and end it there, and we're going to hit tab to move those guys over. Very awesome. Very cool. And now we're going to draw some color using the get color of I and j. And we need to set our y values, so this can be actually j times block size. Because if we're 3 blocks down, then that's going to correspond to, if our block size is 8, then it's going to be correspond to 24 pixels down. And then we need this to be equal to j plus 1 times our block size to make this one actually 8 blocks further than this one. Alright, job well done. Let's hit play, and hopefully we won't get any errors. Hopefully it will just be beautiful off the start. And of course there are errors. I have seen this before, and I had intended to address it before I finished writing the function, but I didn't. This is a slightly annoying thing. GameMaker allows you to do variable arguments, so this should be fine. However, the way the GameMaker compiler works is it still likes to think in its mind that you can't do variable arguments. So it basically goes through here and it says, okay, how many arguments does it take? 1, 2, 3. That's what GameMaker does. It counts 1, 2, 3, and it's like, because you're using argument 0, argument 1, argument 2, it says, okay, this guy takes 3 arguments, that's how many arguments this person needs. But then in get Perlin Noise, of course, I'm still calling it with 2 arguments. And which GameMaker yells because, hey, according to its rather ignorant analysis of my function, it thinks that there's 3. And you can see right here, it's mad at lines 15 and 16 in my get Perlin noise, which corresponds to, of course, the places I'm calling random seed. So the way we fix this is, oops, I don't want to print that. Okay, is we use the slightly lesser known notation of referencing arguments. Rather than referencing them as variables, argument 0, argument 1, argument 2, we're going to represent them as array elements. So they can also be represented as a big array, and we're representing our various arguments as different elements in an array. So this is the alternate way you can represent arguments in GameMaker, and it's happy with this, so this should be fine. Yeah, it's kind of just an arbitrary rule. Don't really know why it's there. And of course, I don't think I've ever made a perfect tutorial where I've made the whole thing without errors. So this is just to be expected. Debugging is a part of life. You should never be upset when your code has bugs. This tells there's an error in random seed line 13. Of course, all kinds of issues there. Line 13, we're saying the seed is equal to ogenerator.seed plus this xx, which we actually renamed to num up here. So we're going to need to rename that over to num. Let's try it again. Fingers crossed, this time it should work. It does, and that looks beautiful. That looks awesome. Let's hit space a few times, and that just makes me happy. I hope it makes you happy too. This is just very pretty. I like it very much. I can spend a lot of time just scrolling through these, looking at the various terrains that we can generate, all randomly. Like, it comes out looking so pretty, despite it just being an algorithm. Computers, man. Computers. Okay. So just a little bit of icing on the cake. What I'd like to do now is, well, this is, improvised here, but just off the top of my head. In Civilization, let's look at Citation Train generation. Civilization 3 terrain selection. Okay, and I'm going to look for images, and hopefully we'll find what I'm looking for. There we go. Okay, that's it. Alright, thank you, PedDigit, for uploading this content back in 2010, because this has what I'm looking for. So, in Civilization 3, in the beginning, you can kind of select your terrain, and you can see the water levels at various heights depending on what you choose. You can kind of see it there. So, how can this be done? After all, our algorithm can do a lot of cool things, but you can see it's roughly 50% water and 50% land all the time. So that's a little bit of icing on the cake. I would like to create a way for us to do something similar. We can decide how high we want the water to be. Alright, so this will involve a fairly simple adjustment to our get color z. We're going to create a variable called water level, and currently the water level is at 50. So we're going to need to just modify our script to be generalized to various water levels. So if our z is less than our water level, we want to paint it blue. And then z, of course, at this point can range between 0 and our water level. So to normalize it, as we've been doing, we must divide it by water level instead of 50. Water level. And then over here, z can be between whatever our water level is and 100. So we're going to subtract water level from our z. And here's the tricky part. This last part is actually not plugging in water level. This last part is going to actually be 100 minus water level. Because if water level is, for example, 70, then z can range between 70 and 100. So to zero it out, we need to subtract water level. However, the range between 70 and 100 is actually 30, not 70. So we do 100 minus water level to get 30. Alright? That makes sense. So let's try plugging in 30. So, or let's try 70. So there's going to be, the water level is higher, so this should look more like islands rather than large land masses. And it does. See, just a bunch of islands that we're generating now. Cool. And that's, what if I want a little bigger island? Let's make it 60 instead of 70. There you go. We have some more decently sized islands, but this is a reasonable archipelago. So yeah, depending on what the terrain you want, you can change it to like archipelago like this. But let's say we want it to be like a large landmass with some small lakes in there. Well, let's do 30. So now the water level is really low, not a lot of water to be seen, and that's what happens. We have a bunch of land with some little lakes. But let's say you want to look like, you know, Michigan with the Great Lakes, and it's just these big lakes surrounding our land. Well, let's try some like 40. Look more like big lakes, and they're bigger lakes. Alright, so this is super neat. I love how much control we have over this and how cool it looks, and that it's random. Like, this is just our algorithm doing creative things, generating cool looking terrain. I kind of got ahead of myself. I'm gonna step back for a second and kind of highlight just point some education stuff out. So let's see, I'm put this back at 50. Now Perlin Noise 2D, just to kind of get a feel for it, I'm gonna take away this loop, because if you remember from our Terraria terrain, we create these big structures, and then with this loop, every iteration we have the structures they have a smaller range of values they can be, but they change more often. So if I play it now without that loop, we should see the most largest of our structures. So this is what it ends up looking like. Oh, that's not good. That's probably an error. The final product looks good, so I'm just gonna leave it up to. Oh no, it's not an error. These are areas where it's like crossed the land threshold. So if I make this, so if I make this 60 instead of 50, you can see it. So from this perspective, you can clearly see that we've sampled different values in here, and it's doing interpolation, linear interpolation between those two values. Like you can see right here, there's a value selected here, 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 and here, and in between those, it's just like fading in between them. If we look back at our favorite article by who wrote this one? I don't actually know. I should figure that out. Perlin Noise. Patrick Lester wrote A Star Pathfinding, and this one is written by wonderful person who taught us Perlin Noise. Who wrote this? I'm gonna say Hugo Elias because that's the name in here, but so I'm gonna credit you for this article. Thank you, Hugo Elias, for putting together this wonderful source of knowledge for us, and of course, thank you, Mr. Ken Perlin, for writing this wonderful algorithm for us. All right, so the thing I want to point out here is this is a little demonstration of the 2D. So what it has here, it's pretty similar to what we have in our version. So see it? And then when they're going down with smaller deviation, higher frequency, you can see they're just smaller squares, and the squares look more and more alike, and you end up with something like this, which is pretty much what we get. So there we go. Now we're at the end of the tutorial. To finish it off, I'm gonna, I'd like to remind you that I am making a total of 6 Perlin Noise related tutorials. So if you like this, maybe you want to learn how to do stuff in Minecraft. I have a Unity tutorial where you learn how to do the same deal to do Minecraft terrain generation. And additionally, let's see, in Unity I'm also going to teach you some 3D Perlin Noise stuff. We're going to make animated Swiss cheese. And let's see, the other thing that I'm going to do is Ken Perlin, the person who wrote this algorithm, did a demo where he showed how you can do like fractal patterns with this. So you can zoom into the terrain infinitely and it'll keep generating. It's pretty cool stuff. So we're going to be doing that in GameMaker. So all kinds of cool Perlin Noise stuff. So stay tuned. And with that, I will sign off, and we'll see you guys next time. Hope to see you again soon.